I shall introduce myself. I'm Chema Garcia. I'm a member and co-founder of CIBER, the Spanish cybersecurity think tank, the first one in Spain. I've spent 10, 15 years, I can't remember actually how long, on cybersecurity. I started as a developer. I've progressed, and now I'm more on the defensive side of things. Something that needs to be taken into account, especially when we're attacked. When you have an incident in your organization, and different scenarios are possible, let's imagine that somebody detects an anomaly on our network, either because something is spreading around the whole of our infrastructure, which may be a malware campaign or an insider script, an insider that knows the architecture that we're using on our network. Once you start seeing that malware spreading internally from then onwards, you can have backdoors, people stealing confidential information, and people hacking user accounts. And the problem with this, and I'm going to use a very basic model here, by the way. Let's imagine we get to work on Monday morning, and it turns out that somebody has detected a problem. Not so much a security issue initially, they think, but some servers or some computers aren't actually working. So that person tries to deal with it as best he can, doesn't talk about the fact that there's this incident. So everything carries on, the attack as well, of course, to Tuesday morning now. The attack is now bigger. It's infiltrated the rest of the network. And what on Monday morning was just 5, 10, or 15 computers that were affected, there are now hundreds by Tuesday. We're going to work in an environment in which, in this case, no alerts have been made, either because they haven't been set up correctly or the person that had to deal with the alerts was actually overburdened with work, something that also happens. And nobody knows exactly what the scope, how far it's gone. All we know is that some computers aren't working or are obviously affected. So, because of the possibility that it might be an attack, the incident response team gets involved, the IR team. So we have to try to find a response to this incident. Whenever you have these kind of scenarios in front of you, you need to have some steps very, very clear in your head. First, you have to detect the incident. That might sound obvious, but if you don't have detection ability, you're not going to be able to do very much. Once you've detected it, you need to identify what assets have been affected by the attack and an initial triage stage to see whether we should try to isolate those assets or maybe allow the attack to spread, but in a controlled fashion. So you can perhaps isolate the affected assets and then analyze what's doing. And that's when I'm going to concentrate most of my talk. When analyzing this scenario, what did we find? Well, different malware samples. So it's not viable to take the signature of one of them to use these deploys and deploy it in the assets. So they're different and they vary. So you can try to contain the attack, but it's a problem to do so. Another characteristic of this scenario may be the use of what we can call allowed tools, permitted tools, tools that are permitted by the organization. If you can talk to any of your colleagues working in systems or any other serious area, you can say, oh, do you use PSXEC? They use it, malware uses it, and so do the attackers. So to get a signature of somebody that had been using this isn't viable either. Different ways that these can spread. Well, they all followed a similar pattern in this case, at common points. At WMI, PowerShell, and SMB. With these three protocols or technologies, you can do all sorts of things. So organizing an attack with these kind of restrictions also throws up some problems. And every time, what makes the commons, every time a different asset is attacked, that is, every time a new machine gets affected, there was a logon event. So that's another problem. Further problems. There were no CMs at all, so we couldn't correlate the information recorded by the machines. What's more, default audit policy, which is all very well to have a general idea, but if an attack that we need to channel what's happened and how it's happened, that's another problem, a further additional problem. The PowerShell version that's being used by our equipment in the company is version 2. So there are no logs or very few logs. So additional problems. And if that weren't enough, the IR team arrives and says, you've got to define or you've got to obtain the scope of the attack. So with all these problems, at the preliminary analysis stage, we've said that there was a logon event every time a new machine was attacked. That was what we said. That's how we know it's being attacked. And this is a screenshot of the security events that you may face when an organization is being attacked. We're talking here about a small organization with a virtually flat network, or if there are different attack focuses. Obviously, if you want to process all by hand, it would be a nightmare. So, if we said that before each attack on an asset, there's a logon event, what are we going to try to search? We have to try to sift through all the information and try to find the event IDs generated by the operating system to try to pinpoint what log-on events have occurred in each machine. And this you actually cross and compare with the log-off events, stating the obvious, of course. And how do we link a log-on to a log-off? Not through the user, because obviously if the attacker attacks several machines, then the ID is going to be the same, but except for the ID, except for the session ID. What's the problem if we do this correlation based on, say, session ID? Well, because it won't be 100% reliable for different computers or different servers. It may well be that there'll be clashes, so it may well be that we've closed a session that's still open. And if you're looking at this with different domains within the organization, then the same problem is true. So it would be valid for an isolated set of computers in the same domain, and as long as there are only very few machines to avoid clash risks. So if we want to track which users have logged onto the system and which have been attacked, how can we detect? So you take logon ID, which we saw earlier, the computer, the domain, and user SID, which is unique for each domain. So if we want to get identificator, you get an you do an SHA-1. At the moment, we don't advise using it because of the risk of collisions or clashes. It's also possible to identify low-profile hijackers. So you can see that. And in this way, if we follow the correlation of log on, log off, you can find which user launches a tool and is trying to substitute another. So what they're doing is using a SRC tracking ID with different attributes to the ones generated by Windows. What kind of useful information will we draw from this? From those user accounts that have been occupied, we'll get hijacked accounts, targeted computers, computer relations, domains relations, and session duration. And what can we deduce from this? Well, all the sessions that last between 6 and 8 hours, which is normally how long a working day will last, we can leave them to one side. But if you can see a session log-on that lasts for 1 second or 2 seconds, that's where we'll concentrate our efforts. This graph is one which is produced by the tool that we're going to look at now. And all of this, what it does is it takes all the information, it processes it, it keeps it in a database, and then very visually shows you which computers are at the origin of the attack launch and which ones have been attacked. Here we can see a user and another one here. These two users have started a session, have logged on in the computers up here at the top and those down below. But what's important is where the user logon comes from. This is the machine where the user was logged on and where they launched the attacks from. So you've got a relationship between destination equipments and original equipments, the place where they launched the attack from. So now we know for sure with this information that all of these computers have been attacked. And getting this kind of information manually and analyzing manually one event or 2 or 3 is a nightmare if you've got very little time trying to trace all this information with all. We've got 5 computers to channel, and imagine if you've got 10, 100 or 500 computers. Imagine the time you need to analyze all that data. So when you've got an incident, what you want to do is to be as quick as possible and deal with information as rapidly as possible. I'm going to show you now how this tool is used. It's called UserLine by this tool. I'll put the link up for you later so you can download it. You can use Docker. It's got Docker Compose, it's got Docker File if you need it. And how does it run? Well, firstly, you need to get the Windows security records. Then you have to process them with a secondary product. Once you've got the file, you run it. Then you launch this tool, UserLine, with the data of the RT search. There you can see it being implemented through Docker to index all the events. And we launch the tool. We say what the server is and which option we want to use. You can run it. By the way, this is just a screenshot that shows the statistics of all the events. So you can index all the events, and it gives you an idea of their reach as well. And here you can see 5,000 events that have been processed in 22 seconds. So it's pretty quick. You can use distributed cache as well. If it's for not very many events, it'll also give you good. It can use internal memory cache, but if you work with large data quantity, then it is necessary. You have to take it out to a secondary server and use the tools together with this cache server as well. So you decide which the cache server is, and you can do it without a problem. This is the output. This is what the data looks like. And I'm going to just show you how it's used. Although the URL will be at the end of the presentation, what you do is type it in and then index with the data that you need. And with that, what's the next command? Well, it's process all the security logs, which are in /data/logs, and we're going to now index it all. This part has been removed. And here what's it doing is it's reading all the security events. There you make a cut of the Docker Compose file, so you can see what's necessary in this case. It uses the image to visualize the data that have been stored. And also, if you want to see the visualizations, it goes to Graphos databases. So we look at all the services, and here you can see the information's been correctly indexed. It's available. You can see it, and then you can launch your tool. There you can see all the information being displayed. 122,129 events. This is also in the repository as well. And here, what we see are all the events. Now they've been indexed. When we've got all the information processed and stored, you can launch the tool. And in this case, we've asked it to show on the screen the most recent events on each computer. And here, what we do is draw all the information of log on and log off in one archive, in one file. So it's easier to integrate. There it is in JSON. And you can see there's a logon input, and then and log off input. So all that information that appears originally in the Windows security event records is also available. And for those of you that are interested in Excel, if you visualize it in Excel, you can do things a lot more quickly. So you can get the same information as in JSON, but with a different format, and in that way look at all the information. And automatically the tool, whatever kind of logon that you've done, it'll describe the event to you. And here we're going to do the same thing, but instead of indexing all the data in Elasticsearch, we're going to do it in Neo4j, which is the database of Graphos. Here's an important parameter, which is unique logon rel. What's this parameter for? If you've got, for example, a user who always logs in from the same machine at the same computer, if they do 200 logs in, when we display them in Graphos database, you will be saturated by information, will be redundant information. So if we only want to know the unique relations, we use unique logon rels, even though there are 200 with the same data, that'll only show us one. So it's a preliminary way of visualizing data that's valid for us. And if we then access Neo 4.0 and we consult in Python, you can see all the different relations between the activity. You can change the colors if you want to. In this case, the green represents a computer, red a user, and mauve domain. And in each relation, you can see what kind of relation, if it's a user with a piece of equipment, whether it's destination. And you can see in each relation below the data relating to each node. If you click on the node, you can get the information about the user, the computer, and if you click on a relation, you'll get data about the relation. Here we've got a user. What will you get at the very least? And you can also set it up that way. You can say, oh, okay, dump all the information that you've got about the event, and you can see it in CSV, or give me minimum information, or just the tracking ID of the activity, the H1 that we mentioned previously, and then to make it more agile, I'll go to F and I'll consult. In this case, obviously you can organize the relations as you want. Look at this computer here and this user. Here you can see that this user always logs on in the same way at this computer and accesses this area. That means that unless it's a specific kind of computer, these relations aren't very legitimate. This machine it will also indicate whether it's a malware kind of activity. In this case, we've taken the tracking ID of a session logon, and there, from all the data, we can filter out whether we want to draw out all the information from the event. In this case, and in the incident that we spoke about earlier, we can see whether it's a session logon network. And it's not just an interactive one. If it's a malware making lateral movements in my organization, you just want to see if it's a network logon. And here, if you put a fight and filter on Neo4j, you can also get what you want. I'm going to go back to the beginning. As we said earlier, it turns out that you want to have all the information processed and you want it in a different index, or if you want to send it via Rabbit to a tool in your organization or one of your tools to process the whole of the event, you can do that. It's all structured and processable in JSON format, and that's the rest of it you've just seen. This is the URL. You can download it from there. The steps that I followed you can have it that way. There's a little set of instructions. So what we've done is we've reduced the time to consult 122,000 events. We only needed 2 minutes. And visually, we've identified the origin of the computer used to pivot the rest of the network. And we can see whether this is legitimate or non-legitimate behavior. And so that's all I wanted to say. If you've got any queries or doubts, either the silence means that I was very good at explaining what I had to explain, or I've done it really badly. Any doubts? Thank you very much.